So hello guys, welcome back to our YouTube channel. Guys, as you all know that we have started with a series of videos on pumps. And now we are started with the types of pump. Guys, following up the videos, we are continuing with the types of pump, and in this video we are going to discuss about gear pumps. Particularly in this video guys, we are going to discuss about what is a gear pump, then how does a gear pump operates, and we are also going to discuss about the external gear pump and internal gear pumps. Okay guys? So now let's get started with what is a gear pump. Guys, a gear pump is a type of positive displacement pump. Guys, here positive displacement refers to a category of pump that displaces a fixed volume of fluid with each cycle or rotation. And in this case of gear pump, this displacement is achieved by interlocking gears. Okay guys, so a gear pump is a type of positive displacement pump and it moves a fluid by repeatedly enclosing a fixed volume using interlock cogs or gears. Guys, here in a gear pump, interlocking cogs or gear is typically consist of two gears with teeth that interlocks. As this gear rotates, they create chamber between the teeth and the pump casing. Okay guys? So now continuing with the definition, a gear pump is a type of positive displacement pump. It moves a fluid by repeatedly enclosing a fixed volume using interlocking cogs or gears, transferring it mechanically using a cyclic pumping action. And guys, it delivers a pulse-free flow proportional to the rotational speed of its gears. Okay? So guys, here in the case of gear pumps, there are few important terms which we need to focus on, from which one of them is a positive displacement pump, okay, where here the displacement is achieved by interlocking gears. The next is the interlocking cogs or gears, which are typically two gears with teeth that interlocks, okay. Then another term which is important in this definition is fixed volume enclosure. Guys, as the gear rotates, they repeatedly enclose a fixed volume of fluid within these chambers. And this fixed volume is determined by the shape and the size of the gears and the pump casing. Okay? Now guys, another important term is mechanical transfer. Guys, the enclosed fluid is mechanically transferred from inlet side to the outlet side of the pump as the gear rotates. Okay? And this transfer occurs due to the cycling pumping action of the gears present. Okay? Another term which we need to focus on in this definition is smooth pulse-free flow. Guys, gear pump delivers a smooth and consistent flow of the fluid without pulsation. And this is because of the gear design and operation, which results in continuous displacement of the fluid without significant fluctuations. And the last term which we need to focus in this definition is proportional flow. Guys, the flow rate of gear pump is directly proportional to the rotating speed of its gears. Increasing the speed of rotation increases the flow rate and vice versa. Okay? So guys, in simple words, a gear pump operates by trapping the fluid between the interlocking gears and transfer it mechanically through a cyclic pumping action, which results in a smooth and pulse-free flow which is proportional to the rotating speed of the gears. Okay guys? This simple definition of gear pump is clear to you. Okay guys? If there arises any question in your mind, do let me know in the comment section below. Now guys, following up in this video, we are moving towards the how a gear pump operates or how a gear pump works. Guys, gear pump uses the action of rotating cogs or gears to transfer the fluids. The rotating element develops a liquid seal with the pump casing and creates suction at the pump inlet. Guys, to understand the working of gear pump more clearly, let's break it out into small parts. Okay guys? So the first point is of rotating gears. Guys, gear pump utilizes the rotation of interlocking gears or cogs to transfer the fluids, and these gears are typically cylindrical in shape with teeth along their circumference. Okay guys? In working, the second component is liquid seal development. Guys, as the gear rotates within the pump casing, they establish a liquid seal between the teeth and the inner surface of the pump casing. This ensures that the fluid being pumped remains contained within the pump and does not leak out. Okay? Now guys, the next component is creation of suction. The rotation of the gear also generates suction at the pump inlet. And this suction effect draws the fluid from the source, such as a reservoir or a tank, into the pump through the inlet port. Okay? Now the next component for understanding the working of gear pump is fluid enclosure within the cavities. Guys, once the fluid enters the pump, it is enclosed within the cavities formed between the interlocking teeth or the rotating gears and the wall of the pump casing. And these cavities form discrete chamber that trap the fluid. Okay? Now it's the time to get discharge. So the next component is transfer to discharge. Guys, as the gear continues to rotate, the enclosed fluid is carried along with them. The fluid moves from the inlet side of the pump towards the discharge side. Okay? So this is where the fluid is reached to the discharge side. Now it is the discharge of fluid outward of the pump. So finally, the rotating gears reach the discharge side of the pump. The trapped fluid is pushed out through the discharge port, and this completes the pumping cycle. And the fluid is expelled out of the pump to its intended destination. Okay guys? In summary, the gear pump operates by utilizing the rotation of interlocking gears to create a liquid seal within the pump casing, and it generates suction at the inlet, draws fluid into the pump, encloses the fluid with the cavities formed by the gear teeth, and then transfer the fluid to the discharge side for expulsion from the pump. This mechanism allows the gear pump to effectively and efficiently work and transfer fluid in various industries and mechanical applications. Okay guys, so this was a brief working of gear pumps. Now guys, we will understand the two types of gear pumps, which is external gear pump and internal gear pump in brief. Firstly, let's get started with the external gear pump. Guys, an external gear pump has two gears that fit together and rotate on a separate shaft. One gear is usually powered by motor, while other drives its own, which is called as idler. Guys, the liquid flows into the spaces between the gears where they move apart at the inlet side, getting trapped between the gear teeth. As the gear turns, the trapped liquid is moved around the pump casing from the inlet to the discharge side. When the gear mesh together on the discharge side, the volume decreases, forcing the liquid out under pressure. And because of these gear teeth are interlocked, there's no backflow between the gears, and the close fit between the gear and the casing prevents leakage and helps suction at the inlet. Guys, external gear pumps have different gear shapes like spur, helical or herringbone, which affect the performance. Okay, so guys, this was a brief about external gear pump. And guys, for this video, at last we are moving towards the internal gear pumps. Guys, an internal gear pump uses gear of different sizes. A large gear, which is also known as the rotor, with teeth inside, and a small gear, which is known as the idler, with teeth outside. The idler fit inside the rotor and is driven by it. As the gear separates at the inlet, they create a space where the liquid flow in and get trapped by the gear teeth. The liquid moves from the inlet to the discharge side as the gear rotates. And when the gear mesh against at the discharge side, the volume decreases and pushing the liquid out under pressure. Guys, internal gear pump only uses spur gears, and a crescentic shape partition inside the casing helps to maintain the seal between the internal and outlet ports. Guys, so this was about internal and external gear pump. Guys, the main benefit of having a gear pump is that the gear pump are compact and simple with a limited number of moving parts. They are sometimes unable to match the pressure generation by the reciprocating pump or the flow rates of the centrifugal pump, but mostly they offer high pressure and throughputs than the vane pump or the lobe pumps. Guys, gear pumps are particularly suitable for pumping oil and high viscosity liquids or high viscosity fluids. So guys, this was all about gear pumps. And guys, that's all for this video where we discuss about what is a gear pump and how does a gear pump operates. So guys, thank you for watching. And guys, for more video related to chemical engineering, process engineering, chemical safety, industrial safety, you can subscribe to this channel. And guys, as always, feel free to leave any questions or comment down below. Thanks for watching. And guys, see you in next video.